In this video, I'm going to lead you through the process of creation of interactive 3D model of our entire solar system. We're going to create models of all 8 planets plus Pluto, because why not? And we also add some major moons to this system, such as Europa or Titan or our own moon. I'm going to split this video in 2 parts. In the first part, we're going to explore the features of this software, and in the second part, I'm going to lead you through the process of creation. Well, the software is a bit big name for it. It's just a simple HTML page file with some JavaScript. Before we continue, I would like to make a few observations. The first observation is that all the planets have the correct information about the surface. So it's all taken from the NASA web pages or from some other sources which have the legit references. Even the clouds, if you can look at the clouds which are moving, they also are taken with satellites. So this information is correct, so there is no some imaginary data present. So the second observation is that all the planets and all the moons are in the same scale. For instance, if you would like to actually compare the planets, you can imagine that you are looking at the skies and you are seeing our moon. So this is the moon of our planet. So you know how big the moon usually is. And now you can imagine that you place some other object, let's say Earth, in place of this moon, and you will understand how big the Earth actually is. So I'm choosing the Earth, and here you have it. So approximately 4 times larger. And the same is true for all other planets. Let's explore our solar system. Start with the moon. If you look at the texture of this moon, you can probably find some familiar features. For instance, I can bet I have seen some of those craters in telescope. And the good thing about this model that you can easily replace the textures to make it more detailed, so you can see more things. But even at this state, it's good enough to recognize some familiar spots on the moon. So this is the moon, and let's look at the first planet, Mercury. So the coloring is a bit enhanced. They claim it on the NASA web page that make it more distinct. You can see more features. But the planet is actually pretty small. If you compare it with the moon, it's almost the same size. So you probably not many people are going to see the difference if you replace moon with Mercury. The second planet is Venus. So Venus is a planet approximately the size of the Earth, and in this model we have 2 layers. So the first layer is atmosphere, is what you see in telescope, and then underneath we have the crust. So I think this image was taken with some sort of radio wave equipment. To penetrate this atmosphere you have to use radio waves, I think. And you see many details on the surface as well. And you also have some dark spots. So for instance here, like maybe there is no data, or maybe there is some sort of alien basis, so they try to hide something, you don't know. So you can look at this planet in more details if you want. The next planet is Earth. We have seen it already. This video is made somewhere on this planet. So the next planet is Mars. Mars is not a large planet. It's comparable with Moon, probably 2 times bigger than the Moon. Maybe if you replace Moon with Mars, some people will do say that Moon became a bit larger, but I'm not sure that everyone will see it. So we have many details again. And you also have the polar caps. So if you are going to visit Mars one day, it's a good idea to take skis. Maybe you can ski from the hills. So we have 2 poles, and 2 of them have some icy surfaces. Yes, and because the size of the Mars is 2 times smaller than the size of the Earth, it's meaning that the volume of Mars is 8 times smaller than the volume of Earth, meaning that the mass of Mars is 8 times less than mass of the Earth, and the gravity and your weight is going to be 8 times less. So just imagine, if you weigh 80 kilograms on Earth, you're going to weigh only 10 kilograms on Mars. It's a pretty good way to drop some extra weight from your body. Okay, the next planet is Jupiter, but the planet Jupiter is huge, 11 times bigger than the Earth, so we have to go far away. So this is Mars on Earth, so this is Earth, and we click the Jupiter. Boom. It's a big planet. And you see my details in atmosphere, so it's a gas giant. And yeah, like this spot is all known. And maybe somewhere inside you have some solid part, let's say metallic hydrogen, maybe not. So this is Earth and this is Jupiter. Then we have Saturn. So Saturn, I think that it has the original texture, not enhanced. Probably what you can see in telescope or what you can get from satellite. Not much going on here. Not much we can see in this texture. Next planet is Uranus. Also a large planet. Okay, next planet is Neptune. Not sure what this is. Looks as if we have the polar caps. Maybe not. But the atmosphere is very thick. You can say it because you see actually the texture. Very smooth. And the last, not a real planet, is Pluto. And Pluto is a small planet. It's called the dwarf planet, and there are a couple of them, and for whatever reason they decided to take this title from this object, so it's no longer a planet. And if you compare it with the Moon, Moon is larger than the Pluto. So this is the Moon and here is the Pluto. Moon, Pluto. So if you put the Pluto on the Moon's place, again it's going to be a bit smaller than the Moon. I'm not sure that people will take notice. So if you put Mercury or Pluto, not all of us are going to see the difference. And now let's visit moons of the solar system. We have many of them, hundreds. For instance, Jupiter has 95 and Saturn has 146. but most of them are small, less than 5 kilometers in diameter. Not a great place to visit, but some of them are pretty interesting. For instance, if you are into barbecue, we can go to Io. It's an active planet with volcanic eruption reaching up to 5 kilometers in height. So lava is shooting in the skies. Good place for barbecue, I think. The next planet to see is Europe. For instance, if you can go skiing there, there's lots of ice and you see this crust, icy crust. And maybe under this icy crust there's some life, because the amount of water underneath is huge, enormous. It's larger than the water we have on the Earth in the oceans. So you might have some civilization down there, for instance, like underwater cities and so on. We don't know. Good place to see. If you bring with yourself a nuclear reactor, you can melt a hole in this icy crust and see what is down there. Also, let's see the biggest moon of Jupiter, Ganymede. And this simply a large moon, and there is not much going on, but it's bigger than the Mercury. So this is the Mercury, and this is Ganymede. And but it's not so heavy because it consists mostly from ice and some rocks. Okay, let's go to Saturn and let's visit the most interesting moon of the solar system, Titan. It has very dense atmosphere, probably denser than the atmosphere on the Earth, and the size of this moon is comparable with other. Well, if you compare it with our moon, so this is our moon and this is Titan. It's larger and you have atmosphere, so maybe if you are into occupying some planets, I would say maybe we should put it on the list, occupy the Titan. And also I think that Venus is a good place to start another civilization, because it has atmosphere as well, but it's too dense and too hot. So I think we need to run some chemical process to condense this atmosphere, and then it's going to be simply a doubler. It's going to be the similar planet to the Earth. Well, Mars is significantly smaller, and there is no atmosphere, so you might be challenging to actually build a civilization down there, but you will see. But you have the pole caps, so you can go skiing anyways. Okay, so those are the moons. We have many other, but I don't know what to say about those planets, about those moons. It's they kind of look the same way. And for instance, when you have this map of all the planets and moons of the solar system, you start to appreciate how lucky we are. Because if you look at the Earth, it's a pretty amazing planet. And also its moon, it's pretty big. It's comparable with the largest moons of the solar system. So this is Titan, and this is our moon, and this is Ganymede, and this is our moon. So it's pretty big. So we're happy, and I think it was put there so that we can occupy it. Maybe be some civilization down there. And if you can take over the moon, Mars is not going to be a big difference, because Mars is not significantly larger than the moon. So probably moon is the best place to start our exploration and occupation of space. And by the way, Mars also has moons. So we have Phobos and Deimos. But those moons are teeny tiny. Not sure if you can see it. Here's the moon. Let's zoom in. Phobos. Small moon. And we also have Deimos. Also small. If you compare it with Earth's moon, you will see a big difference. So this is simply a point, and then our moon. See how big it is? So if you replace our moon with the Mars moon, you're going to see just a point. So you're going to see maybe extra star on the sky. Not very significant object. So we are very lucky that we have such a large moon that we can observe and we can visit. Okay, and let's go back to the Earth. So while we were been traveling on the solar system, something happened on the Earth. The civilization arose. So one particular life form decided to split this region into parts. So you can see the maps of states. And actually this was the reason I wanted to create political map of the planet Earth to see the real size of the countries. When you look at those maps on the 2D map, for instance, here's the same texture. You have a wrong perspective that some countries are huge and some countries are not so big. For instance, Russia, it seems to be a huge country. And this is not because of the area, but because of its location. It's located close to the pole. That's why we have impression that this country is very large, but it's not. If you look, if you put it in the center, so you see the real size. So this is Russia, and this is Africa. Africa is huge, yes. And China is not as small as well. It's almost comparable with Russia. All states are pretty big. And Canada as well. So we have imprinted in our minds that the world map looks like this, but this is incorrect. The world maps, if you would like to study the countries, the best way would be to look at the globe of the Earth and then look at the countries, such as Australia. Australia is pretty huge, as you see. Yeah. Of course, you can Google the real size of different countries and can find those amazing images. For instance, this one. If you look at this, you see the real size, small one, and then the size that is displayed on 2D map. It's a big difference. And for instance, it's quite surprising because apparently US has the same area as Australia. In this image we have the correct size of different countries, so you can look it up and see what is the real size. And all this happens because when the map is built, we build it from different pieces, from small pieces to build the 3D sphere. And when you put it on the 2D, you have the empty spots. So those spots are filled up with area which is not present. For instance, if you look at the Russia, so all this place is empty pieces. And if you connect it, then you have the appearance that when you look at this map on 2D, it looks as if you have a big country, but actually it's just not true. So I had to rewrite my wrong perception of the world, and I decided to buy the globe. So we have different globes, but the delivery takes a couple of days. So we decided to create my own software, this political map. And this is the final result. And now we go into the second part. I'm going to explain the steps I have took to build it. The creation process is pretty straightforward once you have a good co-author, DeepSeek I'm using, and you ask it basic questions and get the basic answers. So my goal was to do it step by step and to control the whole process. So I was using only small simple questions to create small modules, and then I assembled those modules in the whole piece. And for this project I have been using this 3D JavaScript library. So the first question was how to create a basic shape. So I got this shape, and the code for this shape is pretty simple. So this is the code. Just few lines of code and you have this beautiful shape. The next step was to create the texture. So I added texture to this shape. So first you create the texture, maybe in some photo editing software, and then you map this texture to the shape. And I can open this file. So here's the file for the texture. It's almost the same, but you just edit this image. So you add the texture. But you have a problem here, because you cannot load an image from the hard drive. The browser have some new feature, the security feature, so you're not supposed to run it from the hard drive. So you have to use the local HTTP server. I'm using Python, and to run, you can use any HTTP server, but if you are using Python, just simply type those commands. So you move to the directory where your project is, and then run Python server, Python HTTP server, and then type in your browser the title of your page. Okay. Next step was to add mouse rotation. So I can rotate this shape with the mouse. Again, it's pretty simple functionality. And then you add the light. So you have some light source, and you have direct light, basically the sunlight, and you have the ambient light. And also I have added the controls, so I can control the intensity of the light. So I can control the ambient light. Usually it has to be small, but not zero. I found from the experience. And you have the direct light. So there is no sunlight, and now you have it. So at this point it's going from this direction. And the code for this part is here. Okay, so here's the code. So you have two lines to control the light. So you have two elements added to this page file, and you also have the control for the functions. So those are the functions which process the input. Again, pretty simple. So after that, once you have this, you basically have all you need. The next step is you just simply switch the textures. You add some button to choose the different texture, and that's it. You have the program. So I'm using the earth texture, and I'm using the controls. For instance, I can change the ambient light, make it brighter, make it dimmer. I can use the direct light, make it too bright or too dark, and you can use any texture. Let's say a political map. You see that it's a bit too bright, I have to reduce the brightness. So this is the whole software. So it took me half of a day to create it, and I had zero experience of this library. the library that I've been using. So I have no experience, and with help of DeepSeek, I've been able to create this software in half of the day. But then you have to like add some features, maybe add the clouds. Yes, if you want to add clouds, what you should do, you should add second layer. So you create two shapes, and so here is the new function I've added to create a planet. So you have two textures, surface and the cloud texture. And you basically load the texture for the clouds, and then you control the opacity. Opacity is meaning that it's going to be transparent. You have many other options. So it seems to be like a simple task to add clouds to the planet, but eventually you might spend the whole day playing with those options. But what you can do, if you have planets with clouds, you have to add clouds. And now we have Earth with clouds, and Venus with clouds, and Titan as well. As you can see, the creation of planets is pretty simple, but you need textures. So the first thing I have created was the Earth political map, but then I thought, why not to add moon? So I added the moon, found the texture, and I have the moon. Then I think maybe the Mars is going to be a good fit for this project. So I have the Mars. And then I decided to add the rest, all the planets and all the moons. But you need to find textures for them. And I found this beautiful web page. So this page has all that you need. For instance, for the Mars, you have different type of textures, and you actually see the reference from where those textures are coming. For instance, this one coming from the Mariner 9, and you can see actually the source. Also, I found that on the NASA webpage you also have beautiful textures. For instance, for the Venus, I've been using the NASA official webpage. It's an enhanced color map of the Mercury. That's the final result. So you go from the texture to the planet. Basically, in one step, you just have to put a reference on the texture. That's it. And that's about it, I think. So I have this software created, and my globe still in the transit. I haven't received it yet. I have to wait maybe a couple extra days to get it. But that's a good thing, because for a very short time, couple of days, I have created the same map I was planning to buy. So I have this map already, and also I have all the other planets and all the moons in my software. So you probably cannot buy the globes for all the planets. So you cannot see the Mars on this globe, and you can study it. And good thing about it, I can improve it constantly. I can add new textures and do whatever I wish, like even add some not existed planets to our solar system. For instance, like this one. So this is plane from the Star Wars, so you can see the cities. I think it's called Coruscant. Well, why not? Pluto is not a planet, and this is also not a planet. So it's right after the Pluto. So my plan is to improve this software, and I'm going to add the solar system and so on, and I'm going to attach the source code to this video, so you can use it and you can improve it, you can build it. Maybe like I would love to see some improved version of it, or maybe you can add some stuff to it. So let's do it.